accuracy versus precision. It was in the reading for last night, so you should be able to give me some sort of definition of accuracy or precision. Taylor, give me either one. Give me some sort of definition. I'm sorry, I almost heard that. There are two definitions of precision. We're not actually going to talk about that one right now, which is the exactness, which is how far to the right of the decimal, right? That's not the definition we're going to go through today, because that's slightly different than what we're using the definition for today. But that is a correct one. That's not the one I was looking for, but that's fine. Mike.
Accuracy is the grouping of your data points.
Sorry, say that again. Accuracy is?
It's the grouping of your data points.
The grouping of your data points.
How close your data is.
How close what?
How close your data is to itself.
Ah, that is actually not accuracy, that's precision. Okay? So precision is how close your measurements are to one another. Precision is how repeatable your experiment is. Is it repeatable? If you can repeat and get the same result each time, then that makes it, bless you, a precise measurement. What then is accuracy? James? The expected value is an interesting term. The expected value. That's close. We usually use the term accepted value rather than expected, but that's pretty close. So accuracy is how close your measurements are to the accepted value. Now notice, we use the specific term here, how close your measurements are to the accepted value. We don't say the actual value. We don't say any of those other terms. Because what we're referring to here is, for example, the acceleration due to gravity here on planet Earth is 9.81 meters per second squared. But the truth is that it's not exactly that at any specific location. Here at Northville High School, it's actually on the second floor, very close to 9.8049 meters per second squared, so it actually rounds to 9.80. So when we talk about the accepted value, it's simply the value that a bunch of different people who've done experiments have all gotten something close to that value, and they've all agreed, okay, this is the accepted value. It doesn't mean that there is a correct value, because when you do a measurement, there are certain errors associated with it, so it's going to be close to the accepted value, but it will never be a perfect number. It will never be exactly the accepted value. That's why we call it the accepted value. The question looks like this. If the following target is representative of precision versus accuracy, which answer is true? So what I'm going to do is I'm going to put a target on the board. And I'm going to pretend to shoot an arrow at the target. It's going to be bow and arrow. Archery. The reason I choose archery is because in 8th grade, I was in the archery club at my middle school. And we used to go to the gym after school with our bow and arrow and shoot at targets in the gym at the school. Can you imagine a bunch of 13-year-olds running around the gymnasium at your middle school shooting arrows? It's funny how times change, isn't it? It's not going to happen anymore. But I did. Okay, so we're using this as a metaphor to talk about accuracy versus precision. I'm going to be shooting an arrow at the target. We're going to have different arrows that are going to hit the target. We need to make sure people understand when you shoot an arrow at a target, What, Keshiro, are you shooting for? The center. What is the center called, Trevor? The bullseye. In our analogy here, having to do with comparing this to accuracy versus precision, what does the bullseye represent, Susan?
Accuracy?
No, it's not accuracy that it represents. That's okay, Spencer.
Perfect.
No, something specific here, Alejandro.
The accepted value.
The accepted value, right? So to make sure everybody understands our analogy here, the bullseye of the target, which is the center, represents the accepted value. I'm going to shoot several arrows at the target. Now, after I do so, you need to think about which one of the answers, 1 through 7, best matches the arrow shots that I have done. You will do so in verbal silence. You will think about what your answer is, and then I will make sure everyone has their answer before everyone shows their answer. So here we go. Ladies and gentlemen, people, we have, as far as I can tell, unanimity with 1. So everybody thinks it is both high accuracy and high precision. Please explain to me, Christine, why you said, for example, high accuracy.
Because they're all really close to the accepted value.
Because all the measurements are close to the accepted value. That makes it high accuracy. Great. Ginny, why did you say it was also high precision?
Because they're close to each other.
Because what are close to each other?
The points.
The points represent?
Arrows.
In our analogy, yes, but what do they represent as far as accuracy versus precision is? Part of doing this is using the terminology correctly, right? You said use the term they, which was not clear to me. That's why I'm asking for clarity. Lindsay, this is precision because high precision because. We'll come back to Ginny while she's trying to do this. Ginny? You're going the wrong way. Go that way. Go that way. It's okay. It's funny. You said this represented high precision. I'm looking for a precise answer.
What?
Yes. What points? What do the points represent, Rachel?
The measurements.
Because all the measurements are close to one another. It's the points. I don't know what points are. Like, is it a score? So just need to make sure we use the terms correctly. Okay. So we have high accuracy and high precision for this one. Again, it looks like we have unanimity at 2. Carpenter, tell me why you said low accuracy. Because the measurements are not close to the accepted value. Frank, you said it was high precision because? The measurements are all close to one another. Good. We'll do one more. Oh, wait, that was terrible. We'll try again. Sorry, that didn't look like an arrow, so I gotta go like that. There we go. Mostly 6s, some 5s, and some 2s. Mostly 6s, some 5s, and some 2s. Wait a second. Please put them down. 5s and 2s. So we have can't determine precision. We have some people who said we can't determine precision or accuracy. We did have one side we can't determine accuracy. And A 2, low accuracy and high precision. Okay, let's first talk about accuracy. What do we know, Karen, about accuracy in this particular case? We know that our measure point is not near the accepted value. This would give us low accuracy. Right? So we do know that this is low accuracy. Unfortunately, just saying low accuracy is not an answer. So we need to also talk about precision. So what do we know, Christine, in this particular case, about precision? Nothing. Why not?
Because we only have one measure.
And therefore,
We can't really compare it to anything else.
because precision has to do with comparing the measurements to the other measurements. And if there's only one, you cannot compare. Therefore, you cannot determine precision. Therefore, 6 is the correct answer. Good. Now, we do have an equation that has to do with it. So I'm going to write down the equation. I'm going to write down the equation first, and then I'm going to talk about it. So some of you are going to feel compelled to ask me questions. Why don't you wait until after I've talked about the equation first before you ask your questions. E sub r equals O minus A divided by A times 100. And I put a box around it. This is the first of the boxed equations. Boxed equations, anytime I put a box around an equation on the board, you are responsible for, you will be given this equation on a quiz or final exam. So what I would suggest that you do is you find a place in your notebook where you keep track of all the boxed equations, the ones that you're going to be given on a quiz or final exam, so that you have all those in one place. So anything in the box you're going to get on the quiz or final exam. I'm going to explain what all the letters mean outside the box to be clear that you're not going to get the explanation for the equation on a quiz or final exam, but you are going to get the equation itself. For example, E sub r stands for relative error. O stands for the observed value. A stands for the accepted value. So this means, if you were to read it, the relative error equals the observed value minus the accepted value divided by the accepted value, that whole thing multiplied by 100. Relative error. Okay. Is this a measurement of accuracy or precision? Ash.
It is a measure of accuracy.
How do you know?
Because you've got the A and the accepted value.
Because precision has nothing to do with the accepted value. So if it has the accepted value in it, it has to be accuracy. So the relative error is a measurement of accuracy. We do not have, we do have equations for precision, but I'm not going to give them to you. I used to do that. It takes quite a while. They're rather in-depth. And I found that we don't actually end up using them, and the amount of value per unit time was quite low. So we don't actually go through the equations for precision. A couple of other things about this. What dimensions do we get when we use this equation? Dimensions do we get when we use this equation? All right, think it through. Let's say the observed, I'm sorry, go ahead, Meg.
It'd be a percent.
It works out to be a percent. No matter what value you use for, or what dimensions you use for the observed and the accepted value, they will always be the same. Therefore, they will always cancel. And therefore, you're going to get a percent from this equation. Lastly, with having to do with this equation, is there an absolute value in the equation, Claire?
No.
No. So Claire, can you have a negative relative error?
Yes.
Yes. For some reason, people have this feeling that you can't have a negative relative error. You can. It simply means that the observed value is less than the accepted value. So you can have negative